We say we begin with partials. Yeah, just remembering. Partial differentials. Now, as you can see in the notes, partial differentials, they occur when you differentiate a function with respect to more than one independent variables. They occur when you differentiate a function more than one, or rather, with respect to more than one independent variables. They are called partials because the function is differentiated in parts, each part with respect to each of the independent variables. So if we have example 1 here, we have example 1. If we are told y is equals to x squared plus z cubed minus 2 or minus xz. If we are given something like that, the partial differentials, first of all, that one has two independent variables. It has x and it has z. So the first partial will be differential of y with respect to x. That way. So this one will become 2x raised power 1, or just 2x. Now this one will become 0 because it does not have x. Then this one will just remain z because this x, when you differentiate it, becomes 1. So 1 times z, we are just left with, yeah. So in other words, this one settles as 2x minus z. Then if you are told to differentiate dy dz, now this one becomes 0 because it does not have z. This one becomes 3z squared minus this one becomes 1, so we are left with x. So minus x. So this settles as 3z squared minus x. That is how we do a partial differential. We can have example 2. Example 2, if you are told a is a function of 3y squared plus 2x cubed minus 5x y. You're given a function like that. You're told to differentiate. Then the differential of a with respect to y. The differential of a with respect to y will be equal to 6 y. Now this becomes 0. So alafu this is 1. So 5x. So minus 5x. Then the differential of a with respect to x. This becomes 0 because it doesn't have x. This now becomes 6x squared. This becomes 1, so we are left with minus 5y. That's what we call the partial differential. Good. So the next thing that we need to discuss is called integration. It's called integration. Now, integration is just the reverse process of differentiation. The reverse process.
Where are we jumping to?
Which one?
Where are we using? Where are we not using to?
Where?
Very widespread for us to exclude like subjects.
We have used it.
No, you're used later.
Because when I'm differentiating with respect to y, here there is no y, so it comes here.
You only use the one of
Because when you're differentiating a function with we differentiate with respect to an independent variable. So if that independent variable is present, then you multiply like we have done here. But if it's absent in that function, it becomes 0. It's what yesterday we called the constant. Yes.
So we have y equals 0.
Yeah, y. So it's like here we have y raised to power 0. So we multiply here by 0, everything goes. Yeah. Okay. So I was saying that integration is the reverse process of differentiation. So if you have understood differentiation, it is very easy to understand integration. We have 2 types of integration. There is what we call indefinite integration. Now, indefinite does not have limits. And then we have what we call definite integration. Now, definite, it has what we call limits. So let's write this. Indefinite integration. So in the indefinite integration, I want us to have example 1. If we are told to integrate 3x² squared with respect to x this symbol here is read as integrate. So integrate this. Remember, we began by going forward. Going forward was the differentiation. You see, we had begun with the original function. Then we differentiate. And I told you when you differentiate, the answer is called differential. This dy dx. So when we are saying you integrate, we are going back here. We are going back. And therefore, the result of integration is the original function. The result of integration is the original function. And it's also good you take to note that to integrate means to combine. To integrate means to combine or to get the total. And there are three ways in which we get a total. If you want to get a total of anything, there are three ways. There are three ways of getting a total. One, you can add. Number two, you can multiply. And number three, you can integrate. Those, I don't know whether they are captured in your notes or you need to capture them somewhere as part of it. There are three ways of getting a total. You can add. Like kama kuna 10 bob kwa hii mfuko na kuna 5 bob kwa hii mfuko ingine, you just add. Useme niko na 15 shillings. You can multiply. If I know I have 10 chairs in this room and each chair has 2 kilos, so just multiply 2 times 10, I get 20. Or if you are given a differential, you integrate. Now, there are some cases whereby these three methods will give you the same answer. There are some few cases. But in most cases, they don't give the same answer. So it is then required that the candidates get to know which method to use where. For these two, these are things you have done since you were in class 1. This one, for the integration, we use it where there is marginal. When you see the word marginal, marginal is the other word for differential. When you see the differential, when you see the rate, or in other words, when the function has been differentiated, that's when we use what? Integration. Yeah. So the solution to this will be y is equals to 3x squared. You first of all write it that way. You remember we were taking 2 steps when we were differentiating. First of all, we were multiplying. Then we were subtracting. So if you are told to go back, what do? You add back 1, and then you divide by the new power. As simple as that. And then, just a minute, you remember that there used to be a constant which would become 0. Like now, this one has become 0 here. Has become 0. So to represent that constant that could have become 0, we normally add c. Now c is called constant of integration. And once you have added that, you tell us y is equal to, this will cancel. You are left with x cubed plus c. That is what you're left with. If in your question, you already know the value of y, and you also know the value of x, you just put them there and you're able to know the value of c. But if we do not know, like in our case here, we just give it. However, in our applications, when you're dealing with a revenue function, c is always 0. And when you're dealing with a cost function, c is always fixed cost. And because those are the two that we shall be dealing with more, that is really important piece of knowledge. So I think I know. So example 2. We are told to integrate 4x minus 3x raised to power minus 4 plus 8x minus 12. We are told to integrate that with respect to x. What would be the solution? The solution will be y is equals to 4x is currently raised to power 1. So you add back 1, you divide by the new power 1 plus 1 minus 3x currently raised to power minus 4. You add back 1, you divide by the new power minus 4 plus 1 plus 8x, which is currently raised to power 1. You add back 1, you divide by the new power 1 plus 1 minus 12, which is currently x raised to power 0. So you add back 1, you divide by the new power 0 plus 1, and then you add c, the constant of integration. You add c, the constant of integration. So how does that settle finally? This one becomes y is equals to 2x squared plus x raised to power minus 3 plus 4x squared minus 12x plus c. So let's now look at definite integration. Definite integration. So definite integration is where we have limits within which we are integrating our function. It is more useful for area that is bounded by the two limits and the function. And you can see all those things in the notes. So if we have example 1, if we have example 1, if you integrate, you are told to integrate between 1 and 2. You are told to integrate between 1 and 2. X raised power 2 minus 4x plus 3 with respect to x. With respect to x. The solution to this is we normally say area. Area equals. So you take this and you integrate kawaida. So x square you add back 1, you divide by 2 plus 1 minus 4x raised power 1. You add back 1, you divide by 1 plus 1 plus 3x, which is currently raised to power 0. So you add back 1 and you divide by 0 plus 1. Now, unlike the indefinite where we were adding c, here we don't. But if you wish, no harm. But we don't. So instead, what we do, we draw a stroke like that. Now that stroke is read in the range. In the range of 2, 1. 2 is the upper limit and 1 is the lower limit. So in the range of 2, 1. The range of 2, 1. So if we proceed to simplify, this becomes x cubed out of 3 minus 2x squared plus 3x in the ranges of 1 to 2. So what happens after that, you now take this higher power, you substitute it where there is x. So it's going to be 2 cubed out of 3 minus 2 times 2 squared plus 3 times 2. Then you say minus. That's why we say we don't put c, because if you put it here, then when we say minus, you just cancel. So this then becomes 1 cubed out of 3 minus 2 times 1 squared plus 3 times 1. So Pambana, you give me the final answer. What's the answer? Negative 12.
2 over 3. 2 over 3.
At 2 or 3.
No, 2 over 3.
Oh, 2 out of 3.
Yeah.
Exactly. Okay. Do that. Okay. So we can have another one. We are told to integrate in the range of 3 to 5. Uh, 3x squared plus 4x cubed minus 10 with respect to x. If we integrate that on your own, I see. So whoever has joined as captain, change your name so that we know who you are. Use your full names, Harit. So that's
Bwana siku nyumbani sasa. Nawasikia hapo.
Morning to So we are through? Okay. What is the answer? 622. So that is the general background that we can have of the calculus functions, integration and differentiation. The only bit that remains is when we have constraints, but maybe here I will mention it when we have done some other questions. That's when it can already make sense. Yeah. Sasa, let's get to the past papers. So what we have done, the general overview, so we can get to the past papers, starting from the reverse. Yeah, December 2012, question 1. December 2012, question 1. There you can read for us.
Medicine Limited is a pharmaceutical company that manufactures 2 types of cough syrups, Lala and Salama. The total revenue of producing the cough syrups is given by total cost. And total cost function is equals to so where TC is the total cost function, Here is the total revenue function. S is the number of cartons of lala required. The maximum profit makes it.
Okay, so if you are told to get maximum profit, this is how you go about it. First of all, you need to tell us that profit is given as revenue minus cost. So write that. If you're looking for profit, it is revenue minus cost. Profit is usually represented by pi. That symbol is what represents profit. Nataka unisomee the function for revenue. 38,400
Yes.
S.
Minus 36 L squared.
36 S. L squared.
Yes.
Plus
438 X squared.
S.
438 X squared.
S squared.
Plus 2 million.
Plus 2 million. That is the revenue function. Eh?
Into bracket into 1,000.
Or all the figures are in thousands. Eh? Okay. Ready? Now to the costs. Display the function for costs.
1 million minus 486
minus 486
S squared
S squared
minus 324 SL
minus 324 SL
minus 27 L squared
minus 27 L squared. That's all, eh? Good. So copy up that point. Let's open the brackets so that we say pi is equals to minus 38,400S minus 36L squared plus 438S squared plus 2 million minus 1 million plus 486S squared plus 324 SL minus or plus 27L squared. When you open the brackets, that is how it settles. Let's put three terms together. So that this S haina mwenzake, si ndio? So that becomes minus 38,400S. L square, there is this one of 36 and this one of 27. So minus 36 plus 27, we have what?
9.
Minus 9L square. This S square of 438, it has another one here of 486. So 438 plus 486, 924S squared. This 2 million to join this 1 million. So we are left with what? 1 million. This 324, it has no colleague. So plus 324 SL. So that is what we call the profit function. They tell you to develop a profit function, that is the profit function. Now, for maximum profit, the differential of pi, I told you the higher order differentials, they are used in the identification of maximum and minimum points. The point at which we are maximizing or minimizing. And I remember telling you, we will just be confining ourselves to the first order differential. That will be good enough. That will be good enough. So now we want to differentiate. But as we differentiate, we must also remember we differentiate the function with respect to the independent variable. So this function that you want to differentiate has how many independent variables? How many are those? 2. It has S and L. So that brings us to what we have earlier on called partial differentials. So this is a case of partials. So we will say the differential of pi with respect to S should be equal to the differential of pi with respect to L, and all of them should be equal to 0, because at turning point we said it should be 0. The turning point should be 0. That is, let us differentiate now pi with respect to S. So this one, it has S, which is raised to power 1. So it's going to end up as minus 38,400. You see, this one does not have S, so it becomes 0. This one has S, so times 2, that will be 1848 S. This one does not have S, it becomes 0. This one has S, which is raised to power 1. So we are going to be left with what? 324L. S will have become raised to power 0, 1. And this one, we are saying is equal to 0. You call it equation number 1. The differential of pi with respect to L. With respect to L. Now this one does not have L, so it becomes 0. This one has, so it becomes minus 18L. Plus, this one does not have L, comes 0. No L, 0, but here we have L is power 1. So we are going to be left with plus 324s is equal to 0. And this one, you call it equation number 2. We have two simultaneous equations now, which you can solve using matrices, or you can use elimination. So I want us to use elimination. So removing, I told you in deciding which one to remove, you check which one is easier. And it is easier if the coefficients are already similar. You can see the coefficients of S here, they are not similar. The coefficients of L, they are not similar. So to make them similar, we choose which you want to start. So I want to start with which one do you want to remove? Okay, so removing S from equations 1 and 2, equations 1 and 2. Now you copy equation 1 like this. 324L plus 1848S is equals to 38,400. Is that the same thing here? If yes, then this other one is minus 18L plus 324S is equals to what? 0. Now that we are removing S, we must come here and multiply here by 324, and here we multiply by 1848, the opposite coefficients. Multiply by the opposite coefficients. We get, when you do that, we are going to get, for calculator, you give me those figures. 324 times 324. 104976 L plus 1848 times 324. 598 752 S should be equal to 38,400 times 324. 441,600. Now give me 1848 times minus 18. That 3264, which is negative L. This other one, when you multiply, it will be 598, 752 S. And this one becomes 0. So what must we do so that S disappears? Do I add? Do I subtract? We subtract. Great. So if we subtract there, this and this will become 130. $138,240 L is equals to 12,441,600. So from there, divide and tell me L is what? It's 90. So L is 90 units. L is 90 units. Using equation 1 or equation 2, I think it will be easier. Using equation 2, we will have minus 18 times 90 plus 324s should be 0. So solve and tell me s is what? Right. 5 units. Thus, if they tell you now to get maximum profit, maximum profit is equal to those values you substitute them in this profit function. Hii tulikuwa nayo hapa. Minus 38,400 times S, which is 5, minus 9 times L, which is 90 squared, plus 924 times S squared, that is 5 squared, plus 1 million, plus 324 multiplied by S, which is 5, multiplied by L, which is 90. So that is the one that will give us how much?
So 1,028,000.
1,028,000. Or still not confirmed? That's what. Okay. 904,000. So that is how you solve such. So we are going to call it a lesson at that juncture. So you can try to go through what we have done since yesterday or the other day at the functions. Because now tomorrow we shall do just the past paper questions. We shall do the past paper questions to apply what you have been covering. So that by tomorrow or by the end of the lesson tomorrow, we will be done with the syllabus. So that next week now we can do 1 or 2 revisions. Good. So tomorrow's class begins at 8:30, not at 9. I will begin at 8:30. Whatever I normally do tomorrow is what I did today and made me to come a bit late. Okay, so we meet tomorrow. pick up from there.